Hello students, welcome to another session of this solving homogeneous differential equations. So here is the question number 6 of 9.5. Solve the differential equation by showing it as homogeneous. So look at this, there are two dx's. So first try to collect terms with dx one side. So I can write it as x into dy is equals to, I can bring this side y. So it is y dx plus square root of x squared plus y square dx. So I can take dx common. So I can write it as y root of x square plus y square into dx. The question is, you are asked to show it homogeneous. So I can write dy by dx is equals to, it is y plus square root of x squared plus y square equals to x. I brought this dx to the left. Now look, if I take x common in the numerator, look what happens. So here comes y by x, and I can write it as 1 by x square root of x square plus y square divided by x. Okay, now look, x cancels, means you will get x power 0, y by x plus, now look, if I take this x inside the root, it becomes x square. So x square by x square is 1, and y square by x square you will get. Now this is of the form x power 0 y by x. Okay, so dy by dx is expressed in the form of x power 0 f of y by x. That is, the given right hand side function is a homogeneous function of degree 0. Okay, so this implies given is homogeneous differential equation. Now you need to solve it. Okay, so I can call this as 1. So in this you have to put y by x is equals to v. So therefore, as you know the working procedure, if dy by dx is expressed in the form of f of y by x, put y by x is equals to v, that is y is equals to vx, and its differentiation, if we differentiate with respect to x, you will get dy by dx is equals to v plus x dv by dx. Those who have watched the first video of homogeneous, they can understand it, otherwise you can't. Okay, now you make these substitution in this equation, equation 1. So 1 becomes, what is 1? Let me write it. Your 1 is this, dy by dx is equals to y plus square root of x square plus y square by x you have. This is your equation 1. Okay, in this you have to make the substitutions. So therefore, this implies what we will get, dy by dx means this, v plus x dv by dx equals to y as a vx, x square as it is, y square means v square x square divided by x. Okay, always x get cancels. So taking x common, you can do like this also. Let me write in detail. Vx, if you take x square common from the root, you will get x here. Inside the root, you will get 1 plus v square whole divided by x. Okay. Now, if you take x common, x get cancelled with the denominator. So I can write directly like this. So v plus root of 1 plus v square, you will get this. Okay. So now look at this. Both side v. We bring v this side, v get cancels. So we will have x dv by dx is equals to square root of 1 plus v square. So dv by dx, you have to separate the variables. So dv by, bring this down, square root of 1 plus v square is equals to dx by x. Okay. Once the variable gets separated, integrate. So integrating, integration of dv by root of 1 plus v square, integration of dx by, okay, and you know the standard result. Okay, so note down this, integration of dx by square root of x square plus a square or a square plus x square is equals to log of x plus root of a square plus x square. Remember this. Okay, the log of. So using that, it becomes log of v plus square root of 1 plus v square is equal to integration of dx by x is a log x. Plus, if all the terms are in terms of log, keep the constant also in terms of log. Okay. Now, log m plus log n is log mn. So what should I write? I can write it as log of v plus square root of 1 plus v square is equal to log of c into x. Okay, so log m plus log n is log mn. So both side log you can remove. So you will get v plus, okay, if I remove the log, you will get v plus square root of 1 plus v square is equals to c into x plus, this much you will get. Okay. Now replace v is equal to y by x. So y by x plus square root of 1 plus y square by x square is equals to cx. Further, y by x plus, take LCM, this is x square plus y square, under root x square means you will get x out here. This is equals to cx. Or you can transfer this x this side, multiply by x means you what will get? Y plus square root of x square plus y square is equals to c x square. Okay, this x square transferring to the right side. So this is the general solution of the given differential equation. So let's have another example. Show that the given differential equation is homogeneous and solve it. Okay, so first let me write it in the dy by dx form. Look at this. Inside sine and cos, you will have y by x. Okay. So first you need to express it in the form of dy by dx. As it is given that inside sine and cos we will have y by x. Okay. Whenever you get y by x term inside trigonometric or exponential, you have to express it is for dy by dx. So I can write here this term I write first. Okay. So this I can take y sine y by x minus x cos y by x, or one can write directly. Okay, bring dx this side, that we do. Instead of writing dy by dx is equals to I can bring this full term to the left. So numerator as it is, x into cos y by x plus y sin y by x, and one y remains. I can write out here whole divided by this. It is y sin y by x minus x cos y by x, and 1x is this. Okay. Now if I take x common from this, what will get? See here. If I take x common in the numerator, what will get? Cos y by x plus y by x sin y by x whole divided by, if I take x common in the denominator, x into, it is y by x sin y by x minus x is taken outside, is cos y by x into, we have y by x out here. Okay. Now see here, x cancels and you will left with each term is in the form of y by x. So I can write it as f of y by x. Okay. So what does it imply is, given is a homogeneous differential equation. So you can mention this implies given is a homogeneous differential equation. So you need to substitute. So therefore, put y by x is equals to v, because each term is in the form of y by x. So this implies y is equal to vx. If we differentiate this with respect to x, you will get dy by dx is equals to v plus x dv by dx. So make these substitutions in this or in this, no problem. Okay, so you can put directly y by x as a v. So I can call, if I call it as a one equation, so better you make these substitutions in this. So let me write it. So dy by dx means this, v plus x dv by dx is equals to, we have cos y by x, so y by x means v, cos v plus what we had, y by x sin, so y by x means again v sin v divided by, it is y by x sin y by x, that is v sin v plus cos, plus or minus, let me check, minus cos v. This is minus into, we have y by x means v. Okay, so look at this. Now you have to try to separate the variables. So v plus x dv by dx, we transfer this side better, I can transfer this v this side. dv by dx is equals to cos v plus v sin v by v sin v minus cos v into v, and this v this side, that is minus v. Okay, you brought this v this side minus v. So further take LCM. Cos v plus v sin v into v minus v into v sin v minus cos v, all divided by, this is v sin v minus cos v. Okay, simplify this. V cos v plus v square sin v, okay, this into this. Next, minus v square sin v, and this into this, minus of minus plus v cos v, all divided by, what you will get, v sin v minus cos v. Okay, so here v square sin square v square sin square v cancels. V cos v is 2v cos v divided by v sin v minus cos v. And on the other side you have x dv by dx. Now separate the variables. Okay, so separating the variables means you bring all these terms this side and dx by dx this side. I can write dx up, x down, and here v sin v minus cos v divided by this down. You can keep 2 here only, okay, no problem. So you can write it as v cos v into dv. I have kept this 2 here only. Now you can integrate. Integrating both sides, v sin v minus cos v by v cos v into dv equal to 2 into integration dx by x. Okay, have an idea of integration. So if I divide v sin v by v cos v, you will get tan v, because v get cancels. And here if we divide cos v by this, you will get 1 by v dv equals to 2 integration of dx by x. Okay, now you can write the integrations directly. Integration of tan v is log sec v, log of sec v. Integration of 1 by v is log v. This is v. Okay. Integration of 1 by x is log x, plus if all the terms are in terms of log, you can keep constant also in terms of log. Now this is of the form log m minus log n, so I can write log m by n. So log of sec v by v. On the other side, 2 log x can be written as log of x square, and now it takes the form log m plus log n, so log mn, so I can write it as log of x square c. Okay, now both sides you remove. So what you will get? You will get, if you remove the log, your general solution will be sec v by v is equals to x square c, or you can write sec v is equals to x square vc. Now you can replace v as y by x. So sec y by x is equals to x square into y by x into c. So further x cancels here. You can write xy into c equals to secant y by x. So this is the general solution. So practice makes you perfect. So just by watching won't help you. Just let's have another example. Okay. Show that the given differential equation is homogeneous and solve it. Even if it is not asked to show it, just if the question is solve it, then check that whether it is homogeneous or not by looking at the terms. Okay. So if inside sine or cos or power of e is in the form of y by x, it is going to be homogeneous. Okay. Let's make one small correction here. Okay. Nothing is required. Everything is fine. Okay. So here x dy by dx is equal to, first I bring all the term to the right, that is y minus x into sine y by x. Okay. Now divide by x. So if I divide on both sides by x, dy by dx is equal to, you will get y by x minus x by x is cancels. Okay. Now clearly this is a function of y by x. Okay. And here you can write x power 0. So doesn't matter. X power is not there, means you can write x power 0. So this is what given is homogeneous. Given is homogeneous differential equation, back because dy by dx is expressed in this form. Here f of y by x means this full function. Okay, x power 0 means 1. So to show it is in the standard form, I have written it. Now you have to put y by x is equals to v, that is equal to y is equal to vx, and its differentiation dy by dx as v plus x dv by dx. Okay, make all these substitutions in this equation. You can call it as 1. Okay. If you feel my speed is a little bit high, you can slow down. Go to playback and keep it in 0.75 speed. So what will get? 1 becomes your v plus x dv by dx equals to what we had there. It is y by x minus sine y by x. Y by x means v minus sine y by x means sine v. Okay, very simple. Now both side v you have, you can remove this v. So x dv by dx is equals to minus sine v. Now separate the variables. Okay. Separating variables. So dv by sine v, there is only one term with of sine v. Okay, so keep minus as it is. Integration dx by x. Okay. So integrate now. Integrating 1 by sine means I can write sec v, cosec v, sorry. Cosec v dv is equals to minus dx by, okay, 1 by sine I have written as cosec. Okay. Integration of cosec that must be known to you, that is log of cosec v minus cot v is equals to minus log x plus log c. Now you can keep log m minus log n as log mn. Sorry, log m minus log n is log m by n. So if you want to keep this side, I can keep it as cosec v minus cot v. Either you can keep in the form of mod, otherwise no, you understood. C by x. Okay, log m minus log n is log m by n. So both side log you have, so you can write cosec v minus cot v is equals to c by x. Finally, you can replace v as y by x. Equals to c by